Hello, how's it going? This past week I've been building a tool for computing arc resolution, and I am hosting it on this website, which I included in the email. So now I'm going to do a little walkthrough of how one would use the website for computing the configuration, the homology of the configuration of 4 points on the plane. So first I'm going to create a new computation. I'll name it com4 of R2. And so the first thing that we should do is that on a given page, we fill out the details for all the entries. So I'm going to start with the top, and I'm going to fill out all the entries that are zeros. And so we have here, the table is a little too big. It's actually the right size. Okay. So here on the first page, there is no second homology. So by pressing 0, I can fill out the entries with 0. And here, this is going to be the second homology of our space. So what I'm going to do is going to press enter, and a side window pops up. I'm going to add a chain, an abstract group, and now it will be h2 of x, and x being the configuration of 4 points. And I'm going to do similarly here. I'm going to add a first homology, and I'm going to add a zeroth homology. And these are just abstract group, meaning they are placeholder for our quantity of interest. Next, I'm gonna fill out the zero homology, the first row, which is this. And so here, this is going to be here this is going to be 0. This is also going to be 0. And right here, I'm gonna add a chain, and I'm gonna click on diagram chain, and so I can go down and make a new chain. And so here we have 4 points. So I'm just gonna go ahead and add 4 points. 1, 2, 3, 4. And then there's one arc, which is here. And there is one orbiting pair, which I can make by clicking the twist. Select the first point, select the second point, that makes half a twist. Select the first point, select the second point, that makes a full twist. And now I'm gonna copy the chain I just made into this entry and add a new arc to it. And the way I do that is, this is the chain, I go down, I send copy to the next one, and here I have the desired chain in the next entry, the right adjacent entry, and I'm going to go in and add an arc. And so now I'm going to fill out the table by adding the bottom row. And I'm going to do that relatively quickly. Okay, here I accidentally send the copy to the same place, and it made an identical chain here. So now there's 2 chains. So I can press delete chain to delete that. Okay. So now we are done with adding all the chains in all the appropriate places. I'm actually going to go ahead and also add a chain in here. So this is the, I'm going to add a chain with 4 points and no arcs. So, perfect. Okay, now that we have added our chains, the next step is labeling them. So we know that if we have 4 points and one of them is an arc, this is going to be homotopic to the configuration of 3 points in the plane. So what we can do is we can label our chain, this chain, as a generator, because this class does generate homology of arc 3. And so I'm going to go up to the top, go to chain status. I'm going to mark it as generator right here. And similarly with this guy, mark as generator, mark as generator, mark as generator. And this, suppose I don't know whether it's a generator yet, so I'm not going to add it in. But this I know, and this I know. Okay. So now we have done that. Next, what we're going to do is we're going to add our differential arrows by clicking on new arrow, or you can also press the N button, and you can just keep dragging all the arrows to where it needs to be. And notice if a chain, if an arrow begins from an entry with all zeros, or it ends at an entry with all zero, the arrows automatically names it 0. So now that we have done that, let's compute some, okay, so now that we have added the arrows, we can go ahead and start figuring out what the arrows are about. So this arrow is going to be the 0 arrow. It doesn't map from 0, but it maps the generator to 0. So what we can do is we can go into status and we press 0. And this makes it a 0 arrow. And inside arrows, there are a couple of pieces of information. There's the domain of the arrows with all the generators going on here. There is the range with all the generators going on here. And there is the generator relations. So here I have set that x1, which is the generator in the domain, is going to map to 0, which is correct. And x1 here for the range, which is a different x1, they just named it similarly. We can change it if we want, but in this case it's not going to be important. There's the kernel, which we can add and do by hand if we compute it by hand, or we can have the computer compute it. In this case, it says that the generator of the kernel is just going to be the generator of the domain. Next, the outgoing image, you can also have the computer compute it, which is 0. The incoming image is going to be this arrow, which we don't have. But if we don't have anything, then the default is that the incoming image is 0, which is correct. And finally, we could compute homology either by hand or by computing homology. We can also copy the homology from kernel, which is sometimes useful. And it computed homology for us. So this is the homology. So once we have this, the homology, we can copy the homology to the next page. We can copy the homology to E2. So it is copied. We go here and we see that it is copied. Okay. Next, this guy is going to be an isomorphism. So we go up to status and we click isomorphism. And similarly, when we click isomorphism, it's going to auto assign whatever generated on the domain is going to map to whatever generated in the range. And this default option is going to happen when there is only one generator in both the range and the domain. And you can change it. Sometimes you want a minus sign, and you can manually change that. And similarly, we compute the kernel, the image, and homology. In this case, 0. And we copy the 0 to the next page, and we see it. Okay. Similarly, this is going to be the 0. And again, we can compute homology from here too, because we have enough information. Yeah. 0, compute kernel, compute image, incoming image is already given, and then you just compute homology, which is 0. So 0 to the next page. Okay. Finally, for this last map, what I'm gonna do is I'm gonna name it F sub 1. That's just a naming thing. And so on the next page, the kernel is gonna be the homology of this entry here in the next page is gonna be the kernel of F1. So I'm gonna go here, and perhaps I am gonna make a note. I write kernel F1, and similarly the homology at this entry on the E2 page is gonna be co-kernel of F1. And then now we go to the second row and we do the same thing. We go and we compute homology, which is 0, because there's nothing it maps to. So 0. This is gonna be the 0 map, so we can compute kernel, compute homology, and then copy to the next page. And this guy, I'm gonna name it as F2. And similarly to F1 here on the next page, I'm gonna put here, this is gonna be kernel of F2, and this is gonna be co-kernel of F2. Okay. And then finally, we can do the top row very quickly, because everything is 0. Go and compute homology, add it to the next page. Compute homology, add it to the next page. And finally, this entry, we can add to the next page as well. We can send directly to the next page because it's going to survive this homology. So I'm going to send it to page 2. Okay. All right, perfect. So we are on the E2 page, and the first observation is that these 4 entries here are going to be 0. They should be 0. They abuts to 0. Abuts to 0. Abuts to 0. Or I might actually add an abstract group and call it curve F1 and set it as 0. Mark as 0 chain. Okay, so now that we know that these 4 entries are 0, what can we say? We can say that F1 and F2 are isomorphisms. So we set it as isomorphisms. And here we can add a chain. And this is going to be 2 points in a half twist. And 2 point is lying around doing nothing. And this map being isomorphism means that F1, F2 being isomorphism means that this is also a generator. That the image is a generator. And so that H1 is equals to the chain that we just made. And that chain is non-trivial. So we figure out H1 and H0. Now it remains to look at what H2 is. So now we have filled out the E2 page, and we're going to add arrows. We're going to add differential arrows. And there we go. I can hide empty and 0 entries so that it looks clean like this. Now I'm going to compute these differentials, and I'm going to do it in 2 steps. I'm going to compute the bottom D2 first, and then I'm going to compute the top D2. And I'm not going to do it here because it's going to get very messy. This is the clean page, like we see. This is the clean page, which means we're just going to collect all the information that we know for sure on this page. And so for computation, I'm going to create a blank draft. No, delete. I'm going to copy this from clean. There we go. And so this is going to be a draft. And I'm going to name it bottom D2. Now I'm going to start computing. This will be top D2. Okay, so we start here. How do we compute a differential? First, we apply the horizontal differential by clicking apply DH, and what it does is that automatically computes the sum for us, like this. Next, we lift by clicking lift to the entry above. And what this lift does is it basically just copies the information from the bottom entry to the top entry. I thought about having the computer automatically does the lift, but I sort of want to retain the freedom to be able to choose which terms we pair up. So the lift is just going to copy the entries. So we have to do the lift by hand. But that is not hard. What we can do is we can easily compare 2 terms by clicking on the first term, holding shift, clicking on the second term. Then you see the compare 1 and compare 2 option pops up. Now you press enter. So now you get a window with 2 terms like this, and you can compare them easily, and you see that what happened was that this arc moved down and then this point moved up. So we're just going to do that. We are gonna click on the twist, this move down, and this move up. And so now that we have computed the lift, the coefficient should be 1. And now we close it. And now we can delete this guy, delete term. Similarly, we're gonna compare these 2, and we see that what happened is this. Changing the coefficient, and again we are deleting this term. Okay, so now we have this computation. The next thing to do is to apply a horizontal differential again, the face map, by clicking on apply DH. And this is our result. We get 6 terms, which is correct because we have 3 arcs each. So I have 6 turns here. Okay, so now we can look at the 6 turns. By scrolling to these. And what we can see is that the bottom one has a pair of half twists, and the first one has a pair of half twists by itself. So I'm going to start comparing things. Maybe I'll delete stuff. For example, these two are the same in homology. So term 2 and term 3 can go. Delete, delete. Similarly, these two are the same in homology because of this move up to this and this move up to this. So I can delete them. Delete term. Okay, and so what we are left with is 2 of the same thing. 2 of the same chain in homology. Homologous chains. And knowing this, what I'm gonna do is I'm gonna go to this arrow. This is the arrow, this is the D2 arrow. So I'm gonna hide this for now. And then add back the R2 arrow. Okay. This arrow. And I'm going to go to general relations, and I'm going to add an image term which says that the generated in the domain is mapped to 2 times the generated image. And from here I can compute kernel and compute image and compute homology. Oh, and a note, the homology is going to be the homology of the tail of the arrow. So will be of this guy. And having done this, we know what the homology is, we know what the arrow looks like, we're going to promote it to clean. Maybe I'll set it good. I'm just going to rename it for a second. And I'm going to promote this arrow, click on this arrow, and then promote it to clean. And here we see that that arrow gets promoted to the clean version. And there's a redundancy here, so I'm going to delete this guy. Okay, by clicking on delete. Pressing the deleting button. And now we compute the top D2. So applying DH, lifting, comparing them, seeing that this is going to be the case, changing the coefficient to 1, and delete term, and then applying DH again. You see what this is going to be. This is going to be 2 half twist thingy. And similarly, I'm gonna lift this. I'm gonna, let's see. I'm gonna include other chains, and so that in the range I have this option, and I'm gonna add an image term, and it's gonna map to this big differential thing that we just computed. Compute kernel, compute image, and maybe what I should do is I should just not compute homology yet, because I don't know whether this is 0. So I'm just gonna promote the arrow to clean for now. Okay. So this is what we have so far. Okay. So the homology here is 0, so we add 0 to the next page. Where did it go? Okay, I'm just gonna add error manually. Oh, because I'm hiding it. Okay. There we go. Delete chain. Okay. So now we have to think about. Let's rename this. This would be G2. This would be G1. So this entry on the next page is gonna be kernel of G. It's gonna be kernel of G1 over image of G2. And by looking at this, we know that this has to be 0. This is 0. It's going to be the 0 chain. Okay. Which tells me that G1 equals image of G2. Oh, so the kernel of this map. So we know by doing that the kernel of this map is going to be 2 times the generator. And so, okay, compute homology. Okay. And here we have, this is going to be the co-kernel of G1. And by looking at this, we are testing. This is maybe I should add this abuts to 0, and this also abuts to 0. Which means that G1, so G1 is surjective, meaning that this load chain that we have here, that we computed, this is going to be a generator. We don't know if it's 0 or not, but it is a generator. Okay, so let's see. Okay, so using, let's do some computation here. So we know that the kernel of G1, we know that here h2 of x is equals to the kernel is equals to the image G1, which is going to be E2 1 over the kernel G1. This is the first isomorphism theory, which is equals to this guy. Maybe it I should have a name for this. I'm gonna call this chain here. Maybe I'll call this chain something. Maybe I call this B. I don't know. Which is equals to B over 2B. which is this is all isomorphism. So iso equals, which is z mod 2z. This is what we figure out by doing our computation. And we figure out that the first homology is z, and this is z. And we also figure out the generators. Namely, this is this sort of chain. We have one pair of orbiting points, and you have no pair of orbiting points, just 4 points lying around, and you have a copy of Z2 whose generator is given by this sort of situation here. And yeah, so that's how you compute homology of COM4 bar 2 using this tool. Thank you.